So now we will be studying about the sign convention. What is that sign convention? Exactly the way we have studied in our coordinate geometry. We know basic coordinates, isn't it? You have x axis, you have a minus x, then you have a y and a minus y. This is how all over the world it has been decided. Just because I wanted something different, I don't want this as x axis, I want that as x axis. If I want to have it something so different from what the rest of the world is doing, then what happens is, so what we get here, yes, this is also a minus, I am sorry, yeah. So x minus x, then plus y minus y. So this is how we plot the points in a coordinate, isn't it? We want to show. If I say I am at 3, 2, then what does that mean? From this origin, I am at 3 points on the x axis, which is positive, and since y is also positive, I am 2 points here, 1, 2, and I am somewhere here. Every child, everybody will be marking the same way. Nobody will suddenly come and say, no, I am here, because that is how we have decided. It's almost like, deciding even for your directions. You say this is east, this is west, and this is north, and this is south. Who has decided it? I don't think one person has decided, but it has been a convention, and all over the world it is followed like that. So one look at it, everywhere in the world, wherever you go, this is how the north, south is, east, west is shown in a diagram. So that any map, if you look at the map from that city or whatever that place is, you can immediately find out whether you are going towards the north or the south or east or west. That way it becomes easy for all of us to follow one rule. When you follow one rule, it becomes easy for us to do calculations, to exactly locate where we are, where we should go, all those addresses, everything can be done. Similarly, for mirrors, and of course as well as for lens also, which we will do later, of course, there is something called a sign convention. You might have seen that all this while I have been drawing a mirror on the right side and keeping an object on the left side. Do you think it is necessary that I should do like that? What if I keep the mirror, this is a concave mirror, and somewhere here I have the object. Suppose I keep a mirror on this side and keep the object here, do you think image will not be formed? That is not possible, no? Image will be formed, of course, and you will get whatever image you are getting, whatever the nature of image you are getting, the same thing you will get. So it is not that by keeping it here or there, it is going to make any difference how the image is formed. It is how we interpret the image, how certain rules are there which will make us easy for us to understand and do the calculation even without drawing a diagram, whether the image is going to be real and inverted or virtual and erect, small, big, all those things we can learn by not every time drawing the ray diagram, but by doing the basic calculation with the, of course, the formula. But for that formula, as usual, just as you say minus x and plus y minus y, similarly here also we have a standard convention, rule conventions which are there to be followed, so that it becomes easy for us for calculation. So with that, it has been decided, of course, it is not like I have decided, it is a general practice. The image for any concave or convex mirror which we have to get, for that we need that mirror. The mirror is always kept on the right side, okay, and then naturally the object will be kept here in front of it. This is what is known as in front of it. Do not say it is back of it, it is in front of it. So if I keep an object here, it is known as in front of it. So if I mentally extend this pole can be taken exactly the same way you take the origin in a coordinate system, isn't it? This is O, so this is x, y and minus y. So this P we can say it is the same as this. So naturally these distances as it is here are positive in nature, isn't it? Those distances are positive in nature. So if I want to measure something from P beyond here, this distance suppose I want to measure, say it is coming as 4 centimeter, I will take it as plus 4. In which case, if I am keeping an object here on this side, minus x side, then that means distances I measure from this pole to here, say this distance is, this is say focus, and this is say C center of curvature, let this be 5 centimeter, let this be another 5 centimeter, we know that these two must be equal, and let this be say 4 centimeter. Now what is the total distance of this object, say AB, from the mirror? It is 5 plus 5 plus 4, isn't it? So it's 5 plus 5, 10, 14. So I am standing, or rather the object is starting at 14 centimeter in front of the mirror. That distance object distance is, since it is measured from here, I don't measure from here, I measure always from pole. So, the first rule is distances are always measured from pole. On the right side the distances are positive, on the left side the distances are negative. So, these are positive distances, these are negative distances, because I am going to measure from P, just as we measure from O, isn't it? All this number 1, 2, 3, 4, 5 on the positive side, minus 1, minus 2, minus 3, minus 4 on the negative side. So, here also everything is negative. So, object distance is always negative, because you are always going to keep the mirror, later on lens on that side. So, object is going to be kept here only. So, object distances are always negative, whatever may be the mirror, or for that matter lens. We will not confuse now with the lens, let us learn only for the mirror. For both the mirrors the object distance is always negative, because we are going to measure from P this way. So, if I keep it here, somewhere here, if I keep exactly in the focus, then the object distance is minus 5. If I keep it here, it is minus 10. Here it is minus 14. If I keep somewhere beyond here, perhaps it is minus 18, minus 20, minus 25 and so on. So, object distances are measured like this. Wherever the image is, depending upon where the image is formed, we will measure accordingly. In concave mirror, we have seen that most of the time, not always, most of the time, at least in 5 cases, the image is also formed somewhere here, sometimes here, sometimes on the F itself as a point image, sometime at F, sometime at C, same object. If it is here, the image is also formed here, beyond C, then between F and C, whatever it is, in all those cases, image was also formed on this side itself. That means our image distance also will be negative only, because we will be measuring from here. So, object distance is always negative. Image distance is negative if image is going to be formed on the same side of the object. Suppose the image is formed on the other side, like in convex mirror, always the image is formed on that side, in which case the image distance is going to be positive, because image is formed somewhere here. For a convex mirror, the image is always formed here on the right side. So, naturally the image distance is going to be positive. So, object distance is always negative, image distance is negative depending upon where we have kept the object. Depending upon the ray diagram, we will know where the image has come. Sometimes the image comes on the other side also, like in convex mirror. There is also one more position, the 6th position of concave mirror. When you keep the object between F and P, somewhere here if I keep the object, we have seen that the image is formed on that side, which is enlarged in nature, whatever it is. So, since it is formed on this side, again the image distance is going to be positive. So, image distances which are on the back of the mirror are positive. In front of the mirror, please understand this distance is known as the front of the mirror, is always negative. So, images, if on that side is positive, images on this side will be negative. Object is always negative. So, whenever you talk about object distance, it has to be given a negative sign when you do the problems. We will come to that later. So, this is one point, how you measure the distances like this. There is another distance which you measure up and down, isn't it? So, there have been cases when you have, say this is F, this is C, and somewhere here the object is kept. So, what is the position here? Object is beyond C. So, image will be somewhere between F and C, something like this, and it is also going to be small. When you draw the ray diagram, you will get it. You just go through the ray diagram which we have already done, just for comparison. Now, object is above the principal axis, that is a positive y, and this is a negative y. So, what does this mean? Height of the object, as we will do the problem, is always taken as positive. A 5 centimeter tall toy or a candle or a pencil or whatever it is, whatever the number is, that is always taken as positive. If I am having an image upside down, those images heights are taken as negative. So, these heights are positive, these heights which is going below, which is the image height, is negative, and these distances of the image on that side of the mirror is always taken as positive. On this side, if the image is formed, that is taken as negative. Object is always negative, because it is always going to be kept on this side. You are never going to keep an object that side. That is why I told you that if I have a mirror like this, naturally object has to be kept here. This is the place where you are going to get the image. I cannot keep an object here, nothing I can see. So if I keep an object here, now what happens? Now this becomes positive. So a child sometimes takes object distance as positive because he has kept the mirror here and object here. Another child will take the mirror here and an object here, and he will get the object distance as negative. Now which is correct? It is not like which is correct or not correct. Everybody does in a different way, and finally the answers may end up being highly confusing. That is the reason why this rule has been formed. So you keep the object mirror on this side, keep the object in front of it, which is a negative distance. Images can be negative, images can be positive. Object is always positive, the height of the object is always positive. Sometimes the image object is negative because it is upside down. Sometimes the image is also erect as in convex mirror, in which case image height is also positive. So you have object height always positive, object distance always negative.